This is AP Physics Electrostatics video 4. So what I have for you right here are two balloons, and they're attached pretty much down at the floor, and they're helium-filled balloons, and they're separated, right? So what do you know if they're separated in this circumstance? Well, I think you can probably guess that they both have the same charge. So if I take the rod that's negative, my plastic rod, and I hold it near either one of them, both of them will repel away from it. So they both have the same charge. So one of the questions I have for you now is what happens, in as much detail as you can tell me, what happens if I bring my finger over and the Mickey Mouse balloon is going to be the one that's lucky enough to get to touch my finger, okay? So think about it first. Make a little prediction, then I'm going to bring my finger over. I'm going to see what happens, okay? All right, think about it. Ready, set, go. Okay, so you can probably see that they're touching right now, right? So what happened was, I'm not sure if you could hear that one either, but the Mickey Mouse balloon was attracted towards my finger, discharged towards it, right? And then what immediately happened, right? It went over and touched the pink balloon. So why'd that happen? Well, the idea was that with the Mickey Mouse balloon, since it's discharged immediately, if it gave it its excess charge to me and became electrically neutral, and the other balloon still had a charge on it, then of course it's going to attract to that. It's going to be induced to attract towards it, and when it attracts and then it touches it, then what it should acquire is some of the charge that was left on that balloon after it touched it. Now, if seeing them actually touching right now, I don't know if they're exactly touching or they're just very close. I think they are actually touching right now. What does that tell you anyway? Now, if you're thinking deeply about it, you might have said to yourself, okay, the red balloon discharged, got it. Pink balloon still has charge on it, therefore they're attracted. They hit together. And then what should happen when the two conductors hit together? Well, then they should share what charge they had on each one of them, right? So you might have thought that both of them would still be just a little bit repelled from each other, okay? And the fact is that they both might be just a little bit repelled from each other. But guess what else is going on, right? It's the dynamics of the system and the tension in the cords. So that electrostatic repulsion, even though they both are probably still charged a little bit, and I'm going to check that out with my hand here in just a second. If they're still charged a little bit, I should be able to see an attraction for my hand from this one. So I'm going to bring it over here and see if it has some. Yeah, it certainly did. In fact, it even sparked me a little bit. So red balloon, pink balloon, both equal and opposite charges. Red balloon discharges to my hand. Red balloon comes over, gets attracted to pink balloon. Now they share the charge that was on the pink balloon. They're still touching, but the forces of the system are not allowing them to actually separate anymore because of the tension in the string pulling inward. But it did have enough charge on it. You could see that it was attracted to my finger, and it actually still gave me a little bit of a spark. Okay, so now if it sparks me again this time, I'd actually be shocked. I'd be shocked. Let's see if I do. Now this time there's really no attraction at all, because since both balloons were touching last time, right? Since both balloons were touching last time and the red balloon got attracted towards me and discharged, right? I should have been able to take all the charge from both balloons directly to me. And so that's why now there's really no charge there at all. So this is one, I'm not asking you to make any predictions on it in the comments about it, but if you might have to watch this through a couple of times and really think about what I'm saying here, okay? Because it's a little bit complicated why it's doing what it's doing, but see if you can have it make sense to you. So by now they're all neutral, but it took a couple of sparks to get us there, okay? All right, so that's your other video for AP Physics for the second day of Cyber Week. Some other things just to recommend to you. The tippers that I gave you, be sure you're looking at those. Those are great questions. And I'm not exactly sure, in case you're wondering, what we're going to do for any kind of a test or anything on this right now. It kind of depends on how our schedule's playing out, for the second week, and then if there's anything beyond that that we're also doing cyber or whatever's happening. I'm not sure. But anyway, the tippers are great questions, and make sure you're familiar with those, as well as the Explore Learning Simulation, and make sure I get that assignment that I gave you for homework, and of course your test corrections from the spring break test. Okay? All right. Good job, everyone. See you later.